Welcome to CS50 seminar, Introduction to iOS. Thank you all for coming. I hope you're just as excited as I am about iOS. Last year I took CS50 as a sophomore, and I basically learned iOS for my final project, and it was pretty, well, it wasn't easy, but there are lots of support tutorials online, and I really hope that with this seminar, I'll give you guys a head start on iOS development. So in terms of iOS development, there are two main things we want to cover today. First, the language. The language is going to be in Objective-C. Well, actually, here's something really exciting. So you can join the whole Apple community of developers and build some really awesome apps. Also, iOS 7 is beautiful, hopefully, to some of you. But it's controversial, I know. And mainly what I want to do is guide you through Objective-C and also XCode, which is the integrated development environment that you'll be working in for iOS. And so just a word on Objective-C. Basically, it's the exact same as C, but with a lot of other things. And so more strictly, it's actually a superset of C. So anything that you can do in C right now, which is basically like P set 0 through 6, you can do in Objective-C. So don't feel afraid about this new language that you're going to learn. You've already covered a lot of it because you've all done C this past semester, except now you're going to have a lot more to work with. And I'm just going to lead you through a couple of examples to highlight some of the differences, key differences that I found were really important when I learned Objective-C last year. Well, actually, so the other point is Objective-C is obviously object-oriented, and we'll discuss a little bit about what that means later. Basically, it's like how you worked with structs in this past P set with nodes and similar things like that, except in Objective-C, everything is an object. And you're going to be passing around pointers to objects rather than the values themselves. So it's just something important to keep in mind. So why don't we start with a few differences in syntax between C and Objective-C. I want to highlight the include, standard io.h in C and C++ with the Objective-C version of that, which is import and then some sort of file, header file. In this case, it would be uikit, /uikit.h. It could also be, mkmapview /mkmapview.h if you want to do like a map inside of your app. Similar things like that. So the important thing is include has now changed to import. But the idea still remains. You're going to be importing some sort of header file into your program. I also want to highlight the difference between printf and NSLog. However, as we said earlier, Objective-C is a strict superset of C, which means that printf exists in Objective-C too. But most people don't use that. Most people use NSLog because it gives you a timestamp, and we'll see it in action later. But it's generally a more useful way to print out variables. And I also want to highlight that NSLog takes in just the same placeholder values as printf does. So %d is for an int, %f is for a float. However, I do want to highlight this very last one, NSLog %at sign. That is a placeholder for an object. And as I said earlier, Objective-C deals pretty much mostly in objects. And so this will come in useful when you want to print out perhaps maybe an NS array or an NS dictionary or an NS string. So also notice that in our NSLog statement, we have an @ sign in front of the quotation. That is to signify that strings now in Objective-C are objects. They're no longer simply char stars. They're objects and are treated as such. So it's really important that when you use NSLog, it takes in an NS string, which means that you'll have to include an @ in front of your quotation marks. And that's why you see here in all of my function calls to NSLog, I have an @ in front of the quotes, even though the %d and the %fs are all the same from C. Any questions so far? I'll try to go through this quickly so that we can have more time to work with XCode and Objective-C so that you guys can get more familiar with it. Next, I want to highlight something conceptually important. So in C, most things are functions. we make a function call. We declare functions this way with the return type first, then the function name, parentheses, and then whatever arguments and the type of these arguments we want to pass in. In Objective-C, because everything is an object or class, so class and object are two terms that are mostly synonymous with each other, so I may use them interchangeably throughout the seminar. But you'll see that we have methods in Objective-C rather than functions, and methods belong to objects. So just as maybe take, for example, node, our type-def struct node from pset 6 or 5. We have the word property or the next node pointer. Methods are simply functions inside of some sort of structure. So in this case, the structure would be the object, and then the method is something that belongs to an object. And this is how you would declare sort of a method. You would start with, again, the return type. So I tried to highlight I tried to color code the keywords here so that you guys can see the at least formatting similarities between function calls or function declarations and method declarations. So you start with a return type. In this case, it's an array or an NS array pointer. And then you have this method. And then what's interesting here is that instead of having parentheses, we have these colons. And then in front of our argument, we put, again, in parentheses, the type of our argument. So right now, I'm trying to make the comparison between n and number, because they're both like ints. And then the other one is an NSU integer type. And then with Objective-C, when you want to declare or when you want to have multiple arguments in your method calls, you sort of separate them out kind of like this. I'm not quite sure how to describe it, but this is a good example of how you can have multiple arguments in there. You could, of course, just totally ignore the and array colon NS array array if you wanted just a method that takes in one argument. Yes, question.
NSU integer and NSA array are arguments that we take in within the NSA array.
Yes. So let me explain. So yes. So the question was, are NSU integer and NS array star types of the arguments, and that's correct. So you always want to specify what the type of your argument is. And here I'm trying to introduce you to some of the syntax and vocab of Objective-C. So those are actual types that you'll be dealing with. And as you'll notice, arrays are no longer sort of simple bracket things. They're objects. Although if we go on to the next slide, we can see that we can hard code an NS array in Objective-C with simply an @ symbol in front of the brackets. I'm not actually quite sure whether I syntactically hard-coded an array correctly for the C version, but that's supposed to be in a C array. So this is how you would perhaps use the functions or the methods that we created earlier, right? So this is where we declare our function and our method, and now we want to use them in our program, and this is how we would do it. So in C, you would have perhaps a bool b, and you set it to equal the function, and then you pass in the arguments. In Objective-C, it's pretty much the same thing. You have NSArray star myArray, and it's going to equal. Now, the only difference here is this object thing, which I've highlighted in yellow. And as you can see in C, there's no other yellow word. And it's because methods belong with a certain object. So that's why I need to have an object that sort of calls this method on the number 0 and then the NSArray ABCD. Any questions on that? We'll see these concepts in action pretty soon when we go into a demo. OK. Now I want to talk a little bit briefly about XCode 5, which is the integrated development environment that you'll be working with. I know a lot of you, or some of you, don't have Macs, which is a problem because Xcode is not available for Windows and PC. Don't ask me why, but probably, yeah, corporate, whatever. But anyway, so I apologize if some of you do have to download some sort of virtual machine for Mac in order to run Xcode 5. But it is a pretty nifty software to use. And so before we dive into any sort of demo, I just want to show you a picture of what Xcode looks like in your window, and then also talk about what this whole space is. So it's kind of like learning how to use Microsoft Word, except you want to get familiarized with all the different things that are going on here. So first, I want to point you to the toolbar at the top. You'll see that at the top you'll have the file name, or actually your project name and then your file name. Take note of the play and the stop buttons. Those are the ones that you'll be using to run your app on the simulator, the iOS simulator. This automatically comes with XCode 5, so you don't have to worry about downloading some sort of simulator. You just press play, and then it runs your app, and you can play around with it. And you'll see how it works later. And then in the center, of course, is where all of your beautiful code is going to go. And then on the left-hand side, you'll have this sort of folder navigation. And then you'll also see that along with the folder icon, there are a bunch of other icons there that will be useful later. And then on the right side is a utility area where you can work with some of the objects and specify, what the color should be, what the text font should be, etc. Although everything that you do in the utility area, you can do in code as well. And so I'll be going through 2 examples of using simply no code at all or very minimal code versus all code, just so that you guys know what you can and cannot do in XCode and Objective-C. And then finally, down at the bottom, you have the debug area. So you no longer have to run GDB, etc. on your programs. It automatically does it for you. And you can also print stuff to this area. So actually, later we'll go through Mario.c, if you guys still remember that, in XCode. So that should be fun. And then just to bring it back to Objective-C, I want to highlight, what you can do with if statements. So, because Objective-C is a superset of C, everything you do is literally the same as C. You just have slight differences. So you'll notice the form for an if statement is still the same. You have if, and then you have parentheses with a condition inside of it, and then curly braces for whatever you want to do inside of there. However, I wanted to put this slide up here simply to illustrate that because we're dealing with objects now, we will have to use these things called like is equal to string, which is coincidentally a method of a string or an NSString object. So word in this case is an NSString object, and it has a method called is equal to string, and then we're passing in a hard-coded string to see whether those are equal to one another. Any questions so far? OK, and I want to go over a for statement also. So for example, if we wanted to loop over the length of a string in C, this should be familiar to you. And in Objective-C, I do want to highlight this sort of method called count. So actually, count wouldn't be perhaps, well, actually, let me just take that back. Count is a method of array. However, it's more specifically a property of array, which is why you can use the dot notation. But I don't want to get into too much of this conceptual stuff. I just want to show you how things would look like in Objective-C versus C. And also, I do want to point out that even though I've been using NSU integer in front of all my i's in Objective-C, you can also use int, because int is totally valid in Objective-C also. Yes? Yeah, so as you'll see, so the question was, is that just a stylistic issue? As you'll see, I have a sort of star asterisk thing down at the bottom, and that link takes you to a Stack Overflow form where someone explains the difference between an int, an NS integer, and an NSU integer. And so you can read about that later. These slides will be, of course, available to you. Let's see. OK, awesome. So this is also included in the slide because I thought this was a great website that introduces you to Objective-C syntax. So actually, why don't we move to Chrome and check out this website. Right. So what I want to show you guys here is this image. So this is sort of going to be what you're going to see inside of any XCode file. You're going to have, actually, why don't we just take a moment to sort of take this in. So this book, that's the object that we're dealing with. And then it's obviously going to be inherited from some other object, but you don't have to worry about that. and then it perhaps has some member variables. The important thing I want to show you is the instance methods here. So instance methods are denoted by this minus sign. And then as you'll notice, we're already starting to see the paradigm for method declarations, right? The return type, the method name, and then the type of the argument, and then the name of the argument. And this minus sign means that it's an instance method, which means that these methods are only available to objects that have been instantiated. To contrast that, methods with a plus sign in front of them are class methods, which means that you can call these methods even if you don't have an object created yet. So for a clear example, NSString is a class. And you can call, for example, class methods on NSString, the actual word NSString. However, in order to use these methods, you actually need to create a string. For example, NSString star string equals at quotation mark hello world. And then you can use these methods, instance methods, on that hello world string. So that's the difference between instance methods and class methods. And we just covered this part. Properties are another thing that are inside of objects, basically. And you declare them with the at property keyword. You have these options here that I'll explain later when we go into a demo. Yes, hi.
Could you zoom in, please?
Oh, yes, sorry. That should be a lot better. Yeah, please remind me if I forget to zoom in or zoom out. So this is all I wanted to show you for, whoa, that's a lot, for this website. So let's go back to our slides. Actually, now let's take a moment to dive into a demo. So we'll start with a new XCode project. So if you'll open up XCode on all of your machines, it should take you to some page where it says either open up an existing project or a new project, and you should click a new project. And then it should take you to this screen. Yes? Or look on with someone. Yeah. You can chill too. Okay. So what we're going to do first now is actually we're going to do a single view application. So if you'll notice, what's great about XCode and Apple's support for developers is that you have a lot of templates to work with already. You could, for example, make a master detail application. You can make a game. And actually, I won't go into games because games are a different story for iOS development. And they're kind of separate, so I won't go into that. Then you have page-based applications. You have a tabbed application. So what are some, for example, Bank of America probably has a tabbed app. It's the ones where you have the buttons at the bottom. And then you have a sprite kit game. Or you can work from scratch, which is what we'll do later. But let's first start with a single view application. Then it'll ask for a product name, and we can just do test. Organization name. So organization name, company identifier, those are important if you're going to put your app on the App Store. Other than that, your code's going to run absolutely fine without this. This is going to be important if you want to, per se, put your app onto your phone or something and test it out, in real life. This will be important. This tends to usually be associated with some sort of developer account with Apple. And so I know probably a lot of you won't have any developer accounts. I know the university has one. I think CEAS has one. But you can email me, and I'll try to figure that out for you. But right now, I've just put in some placeholder things here. And you can, of course, here choose whether you want it to be solely an iPhone, an iPad, or both. Universal application. So for now, let's do universal, just to see both sides of the platform. Let's see. So right now, I'm going to save it in some sort of folder Doesn't matter where, you can always move it later. And now we are brought to our XCode project. I wouldn't worry about all of this. I would suggest not touching any of this unless you know exactly what you're doing. So all of this, just ignore for the most part. You won't need to touch it. And if you do mess up some things here, it gets a little tricky. So why don't we look into the files on the left-hand side in our navigator. Here we have appdelegate.h. We have appdelegate.m. So as you'll notice, we have header files, which end in .h, and we have implementation. Actually, let me zoom in. OK, let me zoom in. Right, so you have header files and you have implementation files. Actually, OK, this is a little weird, but bear with me. Then, because we've chosen a single view application, we're going to be working with storyboard. So storyboard is something that Apple has come up with to really help developers rapidly prototype their applications. So this is where you can create an app without writing a single line of code. However, in our single view application, we do, of course, have a file for our view, which is a view controller. So we have the header and the implementation file here. And I'm going to zoom out now because we'll need to work in the storyboard. So here's our view. If we simply run the app right now, there's not much exciting going on. So you'll see this white screen. Okay. And in our utilities area, we can add a bunch of different things to it. So when you're dealing with screens in iOS, view controllers are the things, are the objects that encapsulate sort of your views. So a view controller always has a property called view. And that view typically contains what you want to see on a screen. So let's say, well, let's just start by putting perhaps maybe a label. So let's put a label on there. Stick it in the middle. So now that I've clicked on label, I can go into the properties inspector and start changing its value. Let's call it CS50 colors. And I can also change the font. So instead of doing system, which is the default, we can do a custom one. We can change, ultralight, make it 32. And then we can make our box bigger. Yeah, OK. Let's see. Does this work? Sure. OK, awesome. What's that?
What dropdown was the label under?
So the question is, what dropdown was the label under? It should simply be under here. I guess it's this cube thing. But usually this is the default. I'm just scrolling down here until I find a label. And yeah. So now we have our label. Let's center it. And XCode gives us guidelines for centering objects. So now let's run our code again. There we go. So we have CS50 colors. And now let's put a button on there, right? Because we want to make this interactive. So let's put a button here. And we'll call this button tap here to continue. We'll center it also. Actually, it's already centered, yeah. So now we have a button. And if we run this again, we're going to have a nice little button here. And I can click it, but it doesn't do anything because we haven't done anything with the button yet. So let's create another view, right? So let's say I want to tap that button and I want to go to another page, right? Another view. What I'm going to do is I can create a view controller, right? Now I'll click on this tap here on my button, and then the important thing is I'm going to press Control on my keyboard. Control, click on the button, and then drag. So remember to hold the Control key. Let's do that again. So hold Control, click, and drag to what you want to do. OK, and now I have several options here. I can either push, or I can do a modal, or I can do a custom. Push is only if you have a navigation controller. Right now, our very first view controller is not inside of any navigation controller. So the navigation controller is the one that gives you the back button on the iOS app, right? Where you have that top sort of thick bar where you can go back or forward, etc. Right now, I don't have that, and so that's why I can't do a push. So I clicked on push accidentally here, and actually let's run the code, and it should crash on me. Only if I press the button, though. So, right. So this is bad. And as you can see here, we have the error message. So push segues can only be used when source controller is managed by an instance of UI navigation controller. So because this wasn't inside of a navigation controller, I couldn't do that. So right now I'm going back to the folder, going back to storyboard. So right now I'll show you. Let's see. So I'm going to click on this view controller, and then I'm going to go up to product. Editor. And I'm going to go into, actually, did I click on it? No. There we go. I'm going to go up into editor, go down to embed in, and then navigation controller. OK. And my workspace looks really messy, so let's clean this up. So all of this is storyboard. And in this way, I can quickly prototype. OK, stop. I can quickly build something like this, and then I can go back, But this is kind of boring, right? So what I want to do is, I don't want to make just simply a view controller. Let's say I wanted to actually make a table view controller so I can put in some nice colors into the table. So now that I've put in my table view controller, I need to connect it back from this button to the view controller. So I need to do my control, click, drag thing again. And now I can do push because I embedded inside of a navigation controller.
Navigation controller just allows you to go from place to place?
Yes. So more technically, it's an object where inside of the navigation controller object, it keeps track of an array. And that array holds all the subsequent view controllers. That's why when you press back, it goes back to the previous page, because the navigation controller object, or the code that takes care of this object, has an array that keeps track of these view controllers and can then dequeue the view controller and give you back the previous one. So this is technical stuff, but and I'll show you later in code if we have time. I'm kind of running out on time, but so with the table view, what we can do is, it's usually automatically set to dynamic prototype. We're going to make it static cells. Otherwise, we're going to run into some problems. And then let's say I'm going to have one section. So sections is like, if you ever seen the music app, when you have like artists, sections would be the number of artists, or the A's through Z's, the letters. And then the individual rows would be the artist names. And so what's cool here is that I can access all of the objects inside of my storyboard through this drop-down menu too. So I'm going to click on my section, and I want, maybe 5 rows. And then inside of each row, I want to put a label. And I'm going to call this blue. And then I want to put a UI view, maybe for like a little box. So that I can show people a preview of the color. And I'll go back to the property and change that color to, I don't know, this one. And then notice also here, when I have the accessories, I can have lots of the different accessories that you typically see. The disclosure indicator, the detail, or check mark, or simply just detail. So maybe we can do like a disclosure indicator, for example. And then why don't we take these, copy paste them, and put them into the next table row. So we can call this yellow. And I might have to extend this. Let's make it yellow. And in this way, we can copy paste our way down. What was it? Purple. So these are all the typical CS50 colors that you've seen in class. Actually, sorry. Or on the website. Hopefully you guys can see what I'm doing here. OK, last one.
How did you add the row initially?
So the question was, how did I add the row initially? I went into this table section, or however I can select the table section. And then here I updated the number of rows. And let me hope that this works. OK, let's see if this works. Oh, perfect. Awesome. OK. While I was building up my demo, some things weren't aligned. So thanks for the applause. Yeah, so let's see. We'll make this none just to make everything. Or actually, let's just turn all of these into disclosure indicators. And then what I wanted to show you, too, was how I can take each of those table rows and have them interact. Oh, no. So now let's say, like, so sure. Oh, also I want to show you. Here I can put the title of my navigation controller. Right? So actually, you'll notice as soon as I embedded this view controller inside of the navigation controller, we see this navigation bar at the top of our storyboard representation of a view controller. And so this gives us like a visual sort of guide to our visible screen. This is obviously going to be the navigation bar. And what I want to do quickly now is put in another. So here, so this one, right, this table view controller, I did by taking one of these and dragging it here. And that's what's allowed me to quickly really create a table view controller. If we do have the time, though, you'll see that programmatically, it's a little bit more tricky to create a table view controller because there are a couple of methods that are required for you to sort of write out in order for the table view controller to be displayed correctly. However, I just want to show you now an example of where if I take this, for example, I've put in another view controller. And now let's say I want to Control-Alt my very first blue table row to here. And I want to call this blue. And then let's see. I'm at the view now, and I can change the background to blue. And so notice here, this hierarchy gives you, this drop-down menu also gives you a hierarchy of all of these objects. So an important thing to note here is that all of these things here, this table view controller, the table view section, table view cell, all of these are objects in code. So, a label, right now is under the content view, etc. So on and so forth. So if we run this code, we should see something. Let's see if this, yeah. So there we go. But if we don't do that, none of these other things work, right? So only this one works. And for the sake of time, I won't go into putting down the other ones. And this is the end of sort of storyboard, what I wanted to show you for storyboard. And I do have a worked out example actually right here. So this is the storyboard that I made previously. So as you can see, this was my navigation controller. Then I had my first view controller. Then I had my table view controller. And then I had all of these. So previously I was doing something very different. So excuse those things. I'll probably clean it up later before I send it off to production. But if we run this, we'll see that all of the options are available to us. Except I didn't make the backgrounds those colors. So nice, simple application. Now let's try to tackle this programmatically. OK. So to do that, we're just going to start a new XCode project. We'll make it an empty application now because we don't want to have the storyboard. So I'm simply restricting myself to not use any of the storyboard, and an empty application will not give me a storyboard. This is just to prevent myself from cheating. Let's see. Wait, did I? Yes, OK. Right. So here we are left with nothing else but code. So let me move this window slightly over. Right. As you can see here, the only files we're given are appdelegate.h and .m, and we don't have storyboard anymore. So if we run this, we are still going to get to the white screen. Thank God. OK, white screen, but nothing else. And here is the important part. This is where the action happens. In the previous versions, there's usually no code here, but the storyboard essentially provides the code for this part. I won't go into details on how. And what we want to do now is we want to go in here, in this little space, start creating our app again. So, yes. Zoom, yeah, sure. OK, I'll be typing, so this shouldn't matter too much. OK, so first, remember we wanted to create a navigation controller, right? And also, as you can see here, XCode does a really great job of self-filling. So as you'll notice, the names of everything are a lot longer than usual, but XCode fills it in for you. So I can just press Enter. So I want to create a UI navigation controller pointer, and I can call it navigation controller. Now, what do I do now? After this equal sign, I need to first create it inside of memory. So I'm going to do navigation controller alloc. So this is similar to malloc that you guys use in C. And then I'm going to init it. So it's really important that any object that you create, you want to alloc and init it. That's going to create it and instantialize it inside of memory. And now you can use it. All right? If you don't do that, your object does not exist. And you'll run into a bunch of problems. And then I want to create a view controller, right? So I want to create a UI view controller star. So everything is a pointer in Objective-C. And I'm going to do something similar here, alloc init. And then let's say OK. And then what I'm going to do is I'm going to, so remember when we did the embed in navigation controller? This is how you do it in code. You're going to do navigation controller, push view controller. Oh, yeah. No, it likes me better. No, it'll work for you too. So these are all methods. So push view controller is a method, and also more specifically, it's an instance method of the UI navigation controller because I had to create my UI navigation controller star, and then I can call this push view controller method on my specific instance of a UI navigation controller.
So like the exact wording does it already exist for?
Yes, because it's a method. It's like a function. It's like printf. It's like scanf. It's like stir compare, except it knows what you might want to type. And notice that it'll always come up with things that are legally allowed for you. So if nothing shows up here, then something is wrong. So push view controller. So this is how I can quickly, so now I want to push my newly created UI view controller. And then animated, perhaps not, because it's going to be the first view controller. I mean, even if I did make it animated, it probably won't show up because it's the first screen. And remember the brackets. So remember how we used the brackets. And inside the brackets, the object calls on a method. So our object is the navigation controller, and the method is a push view controller animated. And see how it takes in 2 arguments, and they're separated by the sort of words and a colon. So Objective-C tries to make it nice and easy for you to read out loud your code and have it sort of make sense. However, doing just this is not enough. Let me zoom out now. Doing just this is not enough to get what we got to previously. So here you'll notice that there is actually not going to be any sort of bar here, right? There's no navigation bar, which means that we still have not gotten it. And we can test that out also by perhaps changing the background of view controller, right? View controller.background, all right. So see how view controller did not have a background color, even though I wanted to access it? And that's because view controller is a container for the view. So it has a view property, which then has a background color. And I can set it sort of tediously by calling the color on the UI color object. So notice here, red color is a method. It's a class method of UI color because I did not have to create an actual instance of a UI color in order to call the method on it. I just simply called it on the type like name. I called it on int if int had like a method to it, for example. And so if we run this code, we'll notice that the background is actually not red. It's still white. And how we can get around that is notice how there's the self.window. That is like the ultimate container for your application. It is the ultimate thing that contains everything on the screen for an iPhone or iPad application. And conveniently, self.window has this property called root view controller. And that is going to be the pointer to the very first view controller inside of your app. So what we want to do here now is to set that equal to our navigation controller, right? Because technically, navigation controller is our very first view controller. It keeps track of an array of other view controllers, and we pushed this view controller into that array in the navigation controller. So you do not want to do this. That wouldn't really help you. You want to do this if you wanted to do a navigation controller, which most of you probably will because you'll want to sort of have some sort of like menu to go back to or some home page to go back to rather than an empty screen. Yes?
Is it uncomfortable for you to zoom in on?
Yeah. So this should, so yeah, this is the code. And now let's test it out. Whoa. There we go, magic. Okay, thank you. Okay, so now what we want to do is, so we're kind of limited here, right? We could potentially write everything inside of this one function. But that's not how iOS development usually works. So what we're going to do is we're going to create some new files, but more specifically, we're going to create another Objective-C class or another object. Class and objects are interchangeable here. And here's how I could potentially create another class of view controllers. So it's going to be a view controller. It's a subclass, as you'll notice here. It's a subclass of the UI view controller, but I can call it any other name here. I could call this CS50, I could call this view controller, I could call this blah view controller, anything I want. This is just a name for the class. However, it's going to be important because essentially what I'm doing here is I'm creating another class name. So it's going to be like some sort of type or an object. So it should be a little bit generic. It's not going to be very specific. And also, I do want to point out these two options. Because we're doing everything inside of code, sometimes it is a lot easier to bring in an interface file such that I can literally drag and drop, as we did earlier with Storyboard, a label or a button or whatever else. And so zibs are files that allow you to do that. And you have to hook it up to this view controller file. So I'm going to deliberately not check this. Usually I would check this. And if I was also in a single, if I only did this for iPhone or iPad, I would check this and simply have one for the iPhone or the iPad. But since I'm doing universal, I'm going to create two of those later. So I'm going to deliberately uncheck this. This is also really important. A lot of times I've had bugs where this was not checked. And so obviously this file is not sort of like included or imported inside of this test folder. And so my code has absolutely no idea of the existence of this file. And that causes a lot of pain and hours of debugging. But just make sure this is checked so that the target of this file is for this application. OK, so now we've created two new files. And these files look pretty empty. And actually, let's also continue on by creating the zib files. So previously, I was in the Cocoa Touch dropdown. Now I'm going to go into the user interface touch. And as you can see, I can create a storyboard. So even if I started with an empty application, I can still use a storyboard, although it gets tricky in terms of how you want to connect that to your code. So I won't go there. But what we want to do now is create a view. And you can choose for an iPhone or an iPad. And typically, to denote the difference, if you're doing a universal application, you would either put an underscore iPhone or you can do a twiddly. It doesn't really matter. It's simply for you to sort of differentiate which view is for which device. And so now look, I have a screen that I can work with. And so for example, I can put a label on here. And I can also put another button here. I won't bother changing the values here. But what's important here is that the file's owner. So I'm inside of the iPhone view, iPhone zip file. And down in this navigation area or drop-down menu, I want to go to the file's owner. And this is the really important step here. I want to make the class view controller so that this zip file is going to be associated with my view controller. And anything that I do inside of my view controller programmatically is going to be reflected on here. So, however, notice that actually let's also make this let's make this view background blue, for example, just to or green. And then, so if you'll notice, back in this code, this is where we got to our navigation controller. Even though we did that step, it's still going to be red, not green. And there's a reason why. It's because when we initted our view controller here, sorry, it's a little crazy. When we initted our view controller here, we initted it of the general type UI view controller. Okay? So we didn't even do it with this class. So remember, this is like a class now. It can be thought of as a type, just as UI view controller is a type. And in order to use that, what we need to do is import it. Import view controller. And as you can see, it autofills it for me. So view controller. And now here, I can change this UI view controller to view controller. And now here, I can change this to view controller. Let's run this again. It's still red. And the reason why it's still red is because, whoa, what happened there? We wanted to associate this zip file with the view controller. However, in order to actually do that, we need to go into this. And when we do the init, we want to do init with nib name. And then we want to do the @string view iPhone, for example. You can ignore the bundle here. And this is going to allow us to actually there's a problem. Right. And so there's a problem because in our view zip file, we have a label and we have a button. However, even though we've connected those two, there's nothing inside of viewController.h or viewController.m that reflects those buttons or those labels. So we need to write those in as properties of the view controller. So this is how you declare a property. It takes in usually these two options. For the purposes of us and this seminar, I would say that in general, most properties are non-atomic and retain. You can read up on, by Google searching, difference between non-atomic and retain on, Google or something, and it'll take you to like Stack Overflow where people will have answers for the differences between those. But for now, that's what we want to be concerned with. And we want to make a UI label, star, and we can call it whatever we want. We can call this, label. And we'll create another one for the button. And remember to include the asterisks because we're dealing with pointers pretty much everywhere inside of Objective-C. However, that will still not solve the problem, as you can see here. And the reason is because whenever we want to control or connect a zip file label or a button to the program or the header and implementation file, we want to add this piece of code, outlet. Notice that it's a keyword. And as soon as I finish typing that out, it should have these two circles here. Usually they're not filled in. I'm not sure why they are, but usually you will have to manually connect them by going to these this side of the utilities area. And so right now I've got my label selected, and I want to drag this new referencing outlet to my file's owner, and then click on label. So now finally this label is connected to this label. And this label is what we're going to use programmatically to change its text, its font, its background color, etc. So why don't we do the same for the button? And as you'll notice, for the button, it's a little more complicated because it takes in, you're supposed to press on a button. So it's got a lot of options for how users can press on a button. And then we'll see later on that we can connect this to our code to make it work. So for now, though, we want to connect it to the actual button inside of our code. So we go to the new referencing outlet and then do the button. Now let's run this again. Uh-oh, OK. I don't know what's going on here now. Load iPhone, but the view. Whoa. just one moment here. Actually, why don't we take a look at another example in the interest of time? Okay, so here's the more readily prepared example for a view controller. As you can see here, I've included the properties for the label and the button. And then this piece of code here, this IB action, was a connection to this button here. So as you can see here, touch up inside is connected to this selector called button pressed. So we can actually go through the motion again here by taking touch up inside and dragging it to Files Owner, and then click on button pressed. Now let's run our code. So now this button now works and will take us to the next page. And in terms of our view controller, this is the piece of code that took care of the button pressed. And it's important to note here that I've created another type of view controller called a table view controller. So this was similar to back in Storyboard when I dragged one of these table view controllers into the storyboard. I'm creating another pointer to a table view controller, alloc and initting it, and then doing self.navigation controller, push view controller, this new view controller. And I set the animation to yes, because now I'm inside of my app, and I want to actually see the animation going from the home page to the table view controller. What's that? No. So I think XCode, so the question was, do you have to work with garbage collection? In terms of, so XCode 4 had like ARC, which is automatic reference counting. And so usually when you start a new project, you would check that because no one really wants to deal with freeing memory and stuff. But I think in Xcode 5, there isn't even that option on the new project, so it automatically does that for you. Yes?
Can you export a PDF of your storyboard?
Yeah, definitely. Actually, so this will be, all of these will be included in source code. So you guys can check out the actual Xcode project for it. Yeah.
But I mean, like, can I print a PDF of my storyboard? If I just want to export the images to show someone.
Oh, yeah, I think maybe you can just take a screenshot. Yeah, and send them, yeah, a screenshot or something. Yeah. So let's see. In the interest of time, I think that's all I can cover today. But I know that's actually just barely touching the surface of iOS development. So please feel free to contact me if you have any questions about iOS development. And hopefully I'll be able to clean up some of the code for the source code files so that you'll have some really nice examples to work with. Other than that, if you guys are going to the CS50 hackathon, I may or may not be there, and I can help out with some iOS development too. So thanks a lot, guys.